Hello, little people. I congratulate all of you for the wins from Alex Poatan, Shama Pereira, and Usman, the Little Eagle Nurmagomedov. And now we go for our class. Our class is about 1.3 indices or indices, but we don't want to talk about any terrorist organization, so we'll call it indices instead of indices. Okay? So today we're gonna learn about using positive, negative, and zero indices and use the indices laws for the multiplication and division. What the hell is indice? Indice is anything when you see a to the power of n. This whole thing is called indice. Okay. Specifically, this guy is an indice, but it's not important. So what are the rules for it, right? For example, 5 to the power of 2. This is an example for that indices stuff. Okay. The rule is the rule one, the multiplication rule. Okay. Multiplication. How the multiplication works. If we have a to the power of n times a to the power of m, so we call it for same base. If our base is same, then we're just gonna add them up. So a to the power of n plus m. The example, 2 to the power of 3 times 2 to the power of 4 will be equal to 2 to the power of 3 plus 4, which is 2 to the power of 7. Okay? You can think of in this way. What is 2 to the power of 3? It is 2, 2, 2, 3 twos. What is 2 to the power of 4? It is 4 twos, 2, 2, 2, 2. How many twos do I have in total now? I have 7 twos, so it is equal to 2 to the power of 7. You see how it comes up? That's the logic behind it, basically. For the same base again. So you cannot multiply these stuff. You cannot multiply 2 to the power of 5 times 3 to the power of 4, and you can say that it's equal to, I don't know, 6 to the power of 5 plus 4. This doesn't work, okay? Bases, this guy is called base. This guy is called power, okay? So the bases have to be the same. So the second rule is about the division. Division rule says a to the power of n over a to the power of m, again, the bases have to be the same, is equal to a to the power of n minus m. Example for this is 2 to the power of 5 over 2 to the power of 3 is equal to 2 to the power of 5 minus 3, which is 2 to the power of 2, which is 4. And third rule is, well, it's not given here, but you will see that in the questions. It is about this guy, a to the power of n to the power of m. That is equal to a to the power of n times m. What is an example for this? Well, you can have something like this. 5 to the power of 2 to the power of 3. That will be equal to 5 to the power of 2 times 3, which is 5 to the power of 6. Okay? Those are only the three rules that we need to know. And one thing, one bonus says that anything, any number, doesn't matter the number, is n to the power of 0 is equal to 1. Example, 5 to the power of 0 is 1. 2 to the power of 0 is 1. And the reason for that, let's see the reason. Imagine this. Any number like a to the power of n divided by itself, a to the power of n. It's equal to 1, right? Anything divided by itself is equal to 1. Now let's remember this division rule. Like if we didn't know that it's equal to 1, how did we do this division rule? So a to the power of n over a to the power of n should be equal to, let's look at the rule, should be equal to a to the power of n minus n, which is equal to a to the power of, which is n minus n. What is n minus n? It is 0, right? A to the power of 0. So a to the power of n over a to the power of n is equal to a to the power of 0. Also, we know that anything by dividing itself, it's equal to 1. So you see, any number to the power of 0 is the same thing as 1. That's where it comes from. Now, first, let's talk about the negative indices, then work on the questions. So negative indices, how they work. If you have a to the power of negative n, that is the same thing as saying 1 over a to the power of n. Example is 5 to the power of negative 2 is the same thing as 1 over 5 to the power of 2. That's it, nothing. Now let's jump on the first question. We will do 1f, for example. Write each number as a fraction. So look at the rule here. Let's call it rule number 4. So we're going to do f. So 2 to the power of negative 5, right? So we have 8 to the power of negative. That is equal to 1 over a to the power of n. So in that case, 2 to the power of 5. So 1 over, what is 2 to the power of 5? 32. That's it. For example, part C says 9 to the power of negative 2. Again, 1 over 9 to the power of 2, which is 1 over 81. That's it. And now let's go for the question number 2. Here are the 5 numbers. List the numbers of size in order of size, smallest first. So the numbers we got 2 to the power of negative 4, 3 to the power of negative 3, 4 to the power of negative 2, 5 to the power of negative 1, 6 to the power of 0. Let's try to figure out what those numbers are. 2 to the power of negative 4 is 1 over 2 to the power of 4. The other guy is 1 over 3 to the power of 3, 1 over 4 to the power of 2, 1 over 5 to the power of 1, and 6 to the power of 0. We know that anything to the power of 0 is just equal to 1. Now let's try to figure out the results. 1 over 2 to the power of 4 is 1 over 16. 2 to the power of 4 is 16. 1 over 3 to the power of 3, so 1 over 27. The other guy is also 4 over 2 is also 16, right? 1 over 16 again. The other guy is 1 over 5 to the power of 1 is 5. And the last one is 1. So we're going to start with the smallest one. The smallest one is 127. The next smallest one is 116. And they tie with 116. So we have two 116s. The next guy is 1, 5. The next guy is 1. So if you just order them up, the 127 is which guy? 2 to the power, 3 to the power of 3. So this is this one. And the next two are tied. So 4, negative 2, and 2, negative 4. Then we have 5, negative 1. Then we have 6, 0. That's it. And now let's jump into the question number 16. Write the answer to each division as a single power. We got to use it as a single power. So 16, let's say we could do 16c. So we got 5 to the power of negative 4 over 5 to the power of 2. So we know that when we have a division, let's look at the rule. The division rule is just, we just gotta subtract the powers, right? When the base is the same, we subtract the powers. So we have 5 to the power of negative 4 minus 2, which is 5 to the power of negative 6. For fun, we can also do part D. We have 12 to the power of negative 3 over 12 to the power of negative 5, which will be 12 to the power of, we are just subtracting negative 3 minus negative 5. That is equal to 12 to the power of, so you know that minus minus becomes plus. So negative 3 plus 5, which is 12 to the power of positive 2. And negative 3 plus 5 is positive 2, which is 144. But the answer, we have to write it as a single power. So the answer is not 144 because we have to write it as a power. Answer is 12 to the power of 2. That's it. Now let's jump into the question number 17. At last, we have to write down some number as a power of something else. So first, we have to write 8 to the power of 3 as power of 2. Here, guys, you have to see the relationship between 8 and 2, okay? Well, basically, 8 itself is equal to 2 to the power of 3, right? So 8 to the power of 3, instead of 8, I'm just going to write 2 to the power of 3. So this is just 8, right? And I have 8 to the power of 3. So which is our rule number what? Rule number where is that rule though? Rule number 3. You see that a to the power of n time to the power of m is the same thing as a to the power of n times m. Or here we see that 5 to the power of 2, 3, then it will be 2 times 3, which will be 5 to the power of 6, right? So that rule. So we have, instead of 8, we wrote 2 to the power of 3. So 8 to the power of 3 is 2 to the power of 3 to the so 2 to the power of 3 to the power of 3, which will be 2 to the power of 3 times 3, which is 2 to the power of 9. So 2 to the power of 9 is the same thing as 8 to the power of 3. Okay. Now let's jump into, let's say, 27 to the power of, so part F, sorry. So we gotta write 27 to the power of negative 2 as power of 9. That's interesting. Let's do part D first, then we'll go for part F. So part D first. So part D, 27 to the power of negative 2, we gotta write it as a power of 3, as power of 3. Okay. So we know that 27 is the same thing as 3 to the power of 3. So instead of 27, I will write 3 to the power of 3. So this is 27 to the power of, so we get 27 to the power of negative 2, right? So 27 is this, and to the power of negative 2. So it will be 3 to the power of 3 times negative 2, which will be 3 to the power of negative 6. Okay, that's it. And now we're going to write the same number as a power of 9. So F. So now, guys, this is a little tricky, but I'm sure that you can do it. So guys, we know that from part D, we know that, so we got to write, just a second, we got to write to the 27 to the power of negative 2 as power of 9, right? But we don't know the relationship in between 9 and 27. So, well, 27 isn't 9 to the power of any integer, right? We don't know. But we know that this 27 negative 2 is the same thing as 3 negative 6, right? We already shown this in part D. So we got 3 to the power of negative 6 as a power of 9, right? And we know that 9 is equal to what? 3 to the power of 2, okay? Good. This is good. Now, instead of 3 to the power of negative 6, I'll have to show it as a power of 9 somehow, right? So instead of negative 6, I'll write that negative 6 as 3 to the power of, because 9 is 3 to the power of 2, right? So I have to start with 3 to the power of 2. And in order to make it 3 to the power of negative 6, I'll write it as negative 3. Because we know that 2 negative 3 will give me negative 6, right? At the end of, well, this thing is the same thing as 3 to the power of 2 times negative 3, which is equal to a negative 6. So it is the same thing as 3 to the power of negative 6, which is also the same thing as 27 times of negative 2. So 27 times to the power of negative 2. We show it from part D. Okay. So instead of writing, so from part D, we know that 27 to the power of negative 2 is the same thing as 3 to the power of negative 6. Instead of 3 to the power of negative 6, I write it as 3 to the power of 2 to the power of negative 3, because I have to make something related to 9. So 3 to the power of 2 is the same thing as 9, right? This is 9, negative 3. So what we show, we show that 27 to the power of negative 2 is the same thing as 9 to the power of negative 3. And this is the end. See you at the next video.